মোহাম্মদ আলিনুর রহমানকে আমি মঞ্চে আসার জন্য অনুরোধ করছি এবং তার প্রেজেন্টেশনটা উপস্থাপন করার জন্য অনুরোধ করছি। সকলের অবগতির জন্য বলছি যে আমাদের একটা প্রেজেন্টেশন এর সময় হলো 15 মিনিট। তো 15 মিনিটের মধ্যে এটা সময় করলে, যেহেতু আমাদের সব প্রেজেন্টার নাই, আমরা কিছুটা সময় পাবো ইয়ের জন্য, প্রশ্ন উত্তর ডিসকাশনের জন্য। সুতরাং আলিনুর রহমান, আপনি শুরু করেন, আপনার 15 মিনিটের মধ্যে আপনি শেষ করবেন। থ্যাংক ইউ।
Honorable Chair, Co-Chair, distinguished guests, delegates, thank you for participating in this session. I would like to thank the Science and Technology Affairs Subcommittee, Bangladesh Awami League, for organizing a nice and extraordinary conference. Today, I would like to mention about a renowned researcher of my field, Dr. Tanvir Said sir. Thank you, sir, for presenting here. Thank you for your contribution to enhance nature-based solution of wastewater treatment. And I never thought that I will be in the same session with you. So it's my honor. Thank you, sir. So here I am going to start my presentation. First of all, I would like to give my designation. My name is Mohammad Alinur Rahman, and I am from Joshua University of Science and Technology. And my presentation title is Determination of Phyto-reduction Efficiencies of a Murta plants in a vertical subsurface flow constructed wetland system. Here is my study outline. First of all, introduction. I would like to mention about the constructed wetland system, how it works. That's an artificial wastewater treatment system that works with the assembling of biological, microbial, physical, and different chemical processes. And here you seeing a schematical diagram of a constructed wetland here. And I would like to tell you that I would like to enhance the constructed wetland system, because it's the nature-based solution for wastewater treatment. It's very reliable, cost-effective, and no energy is required for the operation and maintenance for this system. And it can support different biological habitat. And I work with specifically vertical subsurface flow wetland system, and that has enormous high reduction capability of biochemical oxygen demand, suspended solid, and pathogens. It has ability to nitrify due to good oxygen transfer, less clogging than the horizontal subsurface flow, and it requires less space than a free water subsurface flow constructed wetland. And one of the most important things of a constructed wetland is wetland vegetation. And different types of wetland vegetations are such like emergent aquatic macrophytes, floating lived aquatic macrophytes, and submerged aquatic macrophytes. And I would like to tell you about a specific types of plant, wetland plant, that has the good capability of phyto extraction from wastewater. Different types of nutrition it can extract. And you all know that about the plant. It is locally called as Murta plant, that is usually used for preparing kulmet. That is called shitolpati locally. Then I used the plant in my research for determining if that has the capability to bioremediate the nutrients from the wastewater. And here is about details about the emergent microphyte species that is perennial, fast growing, and locally abundant. It can grow in shaded and semi-shaded environment. It's a dominant species in nutrient abundant swamps and marshes in different Southeast Asian countries. And here we address the monetary values of the specific plant, a significant contribution to the local handicraft-based economy in the northeastern part of Bangladesh. Numerous items prepared and sold in the global market, such as I already mentioned, cool mat, basket, bag, color bead mat, prayer mat, etc. Then I would share you about why that could be a potential constructed wetland plant. Because it's fast growing, it has higher adaptation capability in an artificial environment, it's perennial, root function develops better, and it's locally available. So the specific target of my study was to finding a cost-effective and nature-based treatment option for the university's dormitory wastewater, to identify the phyto-reduction capability of the selected plant species, and assessing the contaminant reduction capacity of some naturally abundant adsorbent materials. Here is the schematic diagram of my experimental setup preparation. There I prepared two systems. One was planted with the mortar plant and another was unplanted. That is meant as control, and another was the planted system that was experimental. And here is the list, the parameters which I have detected. These are pH, electrical conductivity, total dissolved solids, dissolved oxygen, salinity, resistivity, biochemical oxygen demand, chemical oxygen demand, nitrate and nitrogen. That's the sampling techniques. We determine BOD and COD for 5 different phases, and the nitrate and nitrite for 3 different phases, and pH, EC, TDS, and DO salinity, these were conducted everyday basis for over a 1-month study period. And that's the result. We found that total biochemical oxygen demand, that was BOD5, that was reduced in the planted reactor 61.60%. And in the control system, that was reduced 43.31%. And the reduction was insignificant in the control system. And we hypothesized that dissolved oxygen could have an impact on the planted system. There's the chemical oxygen demand that was ranged between 42.22 to 72.44% in the planted reactor, and 32.22 to 56.1% decreased in the unplanted. The reduction level enhanced at the last phase, and that was statistically insignificant reduction that observed in the both. Statistically significant reduction occurred in the both systems. Here another specific target of our research, that we wanted to determine that if the reduction level get increased with the application of the nutrition doses. Reduction level, we found that reduction rate enhanced with the rate of application of higher organic doses, the plant species could potentially impact the degradation of biochemical pollutants. And we did find no significant reduction was recorded in the control unit that was unplanted. The nitrogen, 50 through 87.09% reduction occurred in the planted unit, whereas 3.12 to 16.12% reduced in the control. And the reduction in the vegetated system was significant. The nitrite nitrogen reduction capacity was also significant in the planted constructed wetland, and the reduction rate got decreased with the application of less nitrogen amount. And we also got that with the application of nitrogen doses, the reduction rate also boost up in the planted constructed wetland. And here we have determined some physical parameters, and we got the fluctuations here. The influent dose was ranged between 7.36 to 8.11 PAs. And in the planted system and control system, it was slightly lower than the influent dose. And it was 6.31 to 7.11 in the planted column, and 6.51 to 7.21 in the control. And PAs could decrease due to the nitrification process occurred in the planted column. And in the salinity, we found that the salinity range was slightly higher in the planted column. And we assessed that, we hypothesized that that could be happened from the mixed effect of evaporation and transpiration process that occurred in the planted reactor. And the TDS did not reduce significantly in the both column, and most probably mineralization and dissolution of ions and inadequate root growth could be responsible for that. And in case of dissolved oxygen, 61% dissolved oxygen increase in the planted system, and the root rhizosphere and atmospheric diffusion might be the great contributor for enhancing the dissolved oxygen rate. Here the electrical conductivity and resistivity. The proportional relationship we could assess between the electrical conductivity and resistivity. And electrical conductivity increased with the planted reactor than the influent level. And evaporation and transpiration might be impact here also. And the mortar plant that could exclude the sodium and chloride ions as their root protective systems. There's the correlation among the physical parameters of the two systems. Significant positive correlation between electrical conductivity with salinity and TDS. And we assessed negative correlation between the resistivity with salinity and TDS. And we also got a positive correlation between pH and DO in the planted column. The planted system could utilize the carbon dioxide from the system. And here is the conclusion of my research. The high contaminants removal efficacy of mortar plant that demonstrate to be a potential constructed wetland plant. And it could be an economically viable and sustainable option for wastewater treatment. And we should carry out more investigation to demonstrate the contaminant reduction capacity of the plant in different wetland systems. And here is the reference. If you have any question, please ask.
Okay, we can take 2 questions actually. Yes.
Thank you for your nice presentation. I would like to know which water would you want to treatment with this plant?
Uh, it might be industrial effluent or maybe domestic wastewater.
So I means if you want to treatment your water, so you should plant your your plant
Yes, yes.
beside your ETP plant, after your ETP plant, or before your ETP plant, or you do not need your ETP plant. I mean, if I want to implement this method for the textile, so what you will do? So do you need ETP or you don't need?
I am specifically mentioning here that we use the plant in the constructed wetland system, and for decreasing the nutrition level or decreasing the contaminants from the wastewater, we used a specific plant species that was used to remediate the nutrition level from the wastewater.
But there is no chemical treatment in
Yes.
this way. So how will you remove the chemical? I mean, our tannery system or our heavy industrial system, our textile system, they use a lot of chemicals, and also they use the heavy metals. So how can you remove them?
Okay, I got your point. You know that in the constructed wetland system, we usually use different types of substrate materials, different types of bioadsorbent, and these adsorbents are capable of absorbing different types of heavy metals or different types of contaminants also. And constructed wetland, the plants also used for remediating different substance that's called the phyto-extraction or phyto-remediation system. And the plant is capable of doing these things, right? So that's why.
Mr. Ali Nur Rahman, you have finished your talk just on time, 15 minutes. Thank you.
Thank you.
And